Hello everyone and welcome to Kotlin and Databases, the mobile developer's guide to backend databases. Today's agenda, I will introduce myself. I will talk about the key database questions for a mobile developer. I will talk about the brief history of databases, the definition of NoSQL and base, SQL and ACID properties, the best practices for SQL queries, which database drivers to use, ORMs, pros and cons, Expose and Speedman ORMs, and last, the Schema Manager. So a little bit about myself. I'm a developer with 14 years of experience. I volunteer at JFocus and other conferences. I teach kids programming after working hours with the project George and Dante. I have spoken at Java 1, Oracle 1, and several JAGs in Europe. And currently I'm learning about Japanese tea ceremony in Stockholm Tea House. This is a picture where the tea house is located in Stockholm, and it has been visited by the Japanese royal family. So, introduction. This is the part of the theoretical part of the talk, and I will cover databases. So, when a developer starts a new backend project, it's faced with 6 questions basically. The first one is what application development strategy to choose, how to analyze the data. Is it structured, semi-structured, unstructured? How to choose a database, SQL or NoSQL? Database drivers, synchronous or asynchronous? If to add a ORM or not? And last, if to use a Schema Manager or not? So the first question is how I should develop an application, which strategy? Should I use bottom-up or top-down? So bottom-up, it means that you start designing the database first, then the business logic, and finally the front end. This strategy is common among large organizations that seek stability. Top-down, in the contrary, you start by creating the front end first, then the business logic, and then the database. This database is common for prototyping or in startups where aims faster time to market. Then we need to analyze the data that application is going to use. So basically there are 3 types. Structured data, which is information that can be mapped to a relational model. So all the raw data that comes from the external entity can be mapped to columns, data types, and rows in a database. An example of this is, for example, a booking system for a car rental. It has customers, you have cars, you have locations, and all this data can be mapped into data in the relational model. Then we have semi-structured data, which is data that might have some structure, but other parts do not have. An example of this is, for example, an email. An email always have a recipient, a receiver, a body, a title. These are the structured parts. But then inside the body, we might have text that is not structured, and it's not possible to structure either. And last, we have unstructured data. And a classic example of this are images. So an image of Mount Fuji and an image of Mount Kilimanjaro, they have nothing in common. To further clarify how the 3 types are, so in structured data, as I said, you can map everything into columns and rows. In semi-structured data, only parts of it can be put into structure, and in unstructured data, no raw data can be mapped into a structure. Now we jump to the third question. How to choose a database. To choose a database, it's important to understand the history of databases. And it started in 1960 when IBM developed a hierarchical model which organized data in a tree-like structure. 9 years later, in 1969, the network model emerged, at the same time that the relational model was invented by Edgar F. Codd while working for IBM. Mainframes kept utilizing the hierarchical and network model until the hardware improves. Around 1977, Larry Ellison and Bob Miner and Ed Oates formed Software Development Laboratories, SDL, that later on will be renamed to Oracle. In 1980, the relational model started gaining popularity. In 1982, Software Development Labs renames to Relational Software Incorporated, later on renamed to Oracle System Corporation. In 1989, SQL Server 1 is launched to OS/2, our IBM operating system. In 1993, SQL Server was ported to Windows NT, becoming popular for small and medium-sized businesses. In 1995, MySQL released the first open-source database, later creating the stack LAMP, that stands for Linux, Apache, MySQL, PHP. In 1988, Carlos Strozzi coined the term NoSQL. Although the database NoSQL is a relational database, the term refers to the lack of support for the SQL language. Around 1999, the SQL Server was ready to compete with IBM and Oracle. Around 2000, the first XML native databases emerged. It's a flavor of document databases, and MarkLogic is the leader of XML databases. Many of the features we see later on in the NoSQL movement originate from the XML native databases. Around 2009, the term NoSQL covered most of the data stores like MicroReduce and semi-structured databases like MongoDB. And in 2021, the majority of the focus is in cloud databases and automation, how to get databases to work with Kubernetes. This is a view of the market share of different database engines. So Oracle is the leader at the moment, and MySQL follows closely Oracle. SQL Server, it's in position number 3, and Postgres, also an open source database, is very popular. MongoDB, which is the first NoSQL database in this chart, followed up by DB2, Redis, Elasticsearch, Cassandra, and MariaDB. The name of NoSQL was in fact used by Carlos Strozzi in 1998 as the name of the file-based database that he was developing. Ironically, it's a relational database just without a SQL interface. The first databases didn't support SQL, neither asset properties. They were what we call today NoSQL databases. The drawbacks of those databases led to the invention of the relational model. NoSQL can be a confusing term compared to SQL. It's important to know the origin and the evolution of the term. NoSQL is not a standard. NoSQL used to stand for without SQL. Now it stands for not only SQL. It has morphed into a philosophy that says we can use SQL, but we have these other options as well. NoSQL databases are not relational. They are usually considered to fall into 4 categories: document-oriented, column family, key value stores, and graph databases. This is an old joke in the database community where they talk about how the NoSQL term replies to different terms during the time. So in the 1970s, we didn't have any SQL, so then we have NoSQL. In 1980, we have NoSQL as NoSQL. And in 2000, there were the star movement where the people didn't want to use SQL at all. And in around 2005, there were so many options that not SQL meant not only SQL. And finally, in 2013, after playing around with NoSQL, then the people came back to no, we want SQL back, please. So let's look at the base properties in terms of database transactions. So basically available means that basic reading and writing operations are available as much as possible. The soft state is when we only have some probability of knowing the state of the database. And eventual consistency says that the database guarantees that if no new updates are made to the object, eventually all the accesses will return to the last updated value. To understand the differences between the different types like SQL and NoSQL, it's very important to look at the properties that transactions has. Base stands for basic available, soft state, eventual consistency. Basic available means that basic reading and writing operations are available as much as possible. Soft state means that we have only some probability of knowing the current state of the database. And eventual consistency means the database guarantees that if no new updates are made to the object, eventually all the accesses will return the last updated value. Here we have the first example between MongoDB and Kotlin. We're going to look into 2 classes, the database controller and the Fruitbox repository. The database controller is responsible setting the connection and choosing the bucket between the database and the application, and mapping the data with the method getCollection. So this allows us to retrieve data from the Mongo database based on the parameters. The Fruitbox repository allows us to retrieve type safely the data from the Mongo collections into the Kotlin services. Now we're going to look into database transactions with asset properties. The first property stands for atomicity. Each transaction is treated as a single unit. The second property is consistency, which means that the database moves from one valid state to another. The third property is isolation, which the transaction can be executed concurrently. And the last property stands for durability. Whatever transaction is committed, it will remain committed. Now we're going to look into structured query language. As I said, the relational model was created in 1969, so it took 5 years for the industry to create the first language to access the relational model, and it was created by Donald Chamberlain. SQL became a standard in '87 and is designed for handling structured data. Many developers work heavily with ORM solutions, forgetting the best practices for writing SQL queries. To write maintainable queries, the SQL statement should prioritize correctness, readability, and then optimization. The order matters. The rule of thumb is this: the earlier list below you can eliminate data, the better. So we start with from and join. Get the table's reference in the query. These tables represent the maximum search space specified by the query. When it is possible, limit the search space before applying filters. Where filters data. Group by aggregates data. Having filters out aggregated data that doesn't meet the criteria. Select grabs the columns. Avoid star operator if possible. And if there is any duplicates, apply distinct. Union merges the selected data into result sets. And then order by sorts the results out. The fourth question that backend and application developers meet is which type of database driver should I use? Basically, there are two types of drivers. The GDC synchronous type, which are deterministic, easy to debug, but they do block the connection until the data is retrieved. Or the R2DBC asynchronous type, which do not block the connection when they query the data from the database. They are harder to debug, but they allow higher loads. Let's look into a code example with a Kotlin application using asynchronous database access. So the first step we need to do is declare the reactive CRUD repository. This will allow us to retrieve the data without blocking the database. And then in the service, we declare that what we're returning is a flux or a flow. And this will allow us to retrieve data without blocking for other queries. So, which one should I use? If the loads are low, I recommend to use the synchronous drivers because it's easy to debug. But if you have very high loads of data, then I recommend to use the R2DBC asynchronous type. The fifth question that backend developers face is how to access the database. They wonder what is an object relational mapping tool for, and basically the answer to this is generating SQL queries and mapping its results to objects. They also wonder what can an ORM do that SQL cannot, and basically it is caching at application level, several the journey from the application into the database and back. Last, they wonder, should I use an ORM, plain SQL queries, or both? We're going to try to answer this question in the next slides. The ORM advantages are many. They save time writing SQL queries and mapping the results to objects. They provide an abstraction layer over databases, avoiding vendor lock-in. And they usually shine with small and simple database schemas, similar to the ones seen in microservices. I also would like to highlight that Gavin King, the Hibernate creator, he quoted saying, "Hibernate builds on GDC, it does not replace it." The ORM disadvantages are many, and this is a complex topic. Basically, when ORMs are used in scenarios that are not well designed for, they tend to have different problems. I'm not going to enter and explain each topic because it could take hours, but I would like you to read more about them and try to understand them. The problem with this list is that it gives a very high cognitive load of learning all these problems. The ORM disadvantages are many. The ORM disadvantages are many. Basically, when a developer uses a ORM solution in a non-suitable ORM scenario, these problems tend to show up. And I have added one myself to this list, which is the cognitive load of learning all these problems as a developer. Basically, all the time that we save writing SQL and mapping to the objects, they have to be balanced with these problems that they show up when dealing with very complex schemas or with applications with performance problems. The ORM market is basically the dominant solution. So this is to give another point of view on the applications. So we can say that the 60% of the applications of the JVM ecosystem use some kind of ORM tool, either Hibernate or Eclipse Link or MyBatis or other. And then other tools or the same applications use to some extent plain JVDC or Spring JVDC template, which is a pure SQL solution without ORM in between. Also, I would like to note that developers could choose more than one answer, so the totals do not equal to 100% in this survey. As a Kotlin developer, it's very important to be familiar with Expose, ORM created by Maxim Shafirov, CEO of JetBrains, around July 2013. It's the first ORM written purely in Kotlin, and it is used internally at JetBrains in several products, which means it's tested in production. Here below we have the link to the project. Now we're going to see a screen application done with Codelinexpose. So, Codelinexpose, it's very intuitive and very easy to learn. Here we have a repository done using Codelinexpose, and we can see how easy it is to add code to using the schema utils and the fruitbox table to insert statements. So this is the power of having a DSL language in dealing with ORMs. And as we created the interface or the repository, then we can use it in any service. So we create a service for fruit service, and we basically use the fruit repository, and then we can access all the data exposed by Codelinexpose or the database in very simple methods. So it's the easiest approach as a Kotlin developer to access a database. The good parts of Codelinexpose is that it's type safe, it has a small learning curve, it's lightweight, and there is no boilerplate as we saw in the code sample. The improvement areas are documentation, developer experience in terms of usability, support of data classes instead of entities, and a graded plugin for migrations. I would like to thank Andrei Tarashensky, the main maintainer of the project. And also there is a very good link to Bildung, where you can learn more about the persistence. Now there is another alternative ORM that is called Speedman. The reason why I bring this ORM tool is because it's been used successfully. As a Kotlin developer, we can use the best frameworks from the Java world, and one of them is called Speedman, a ORM that has also provides type safety, has been created with Java 8 streams in mind, has also a very small learning curve, and it does data model first. The improvement areas is that some of the SQL scenarios cannot be implemented with Speedman. And the last topic, or the last question of the project is, should we use a Schema Manager? So we could use an abstraction layer of ORMs to avoid vendor lock-in, but another alternative I would like to show developers is actually using a Schema Manager like Liquibase. And they provide an abstraction layer to avoid vendor lock-in. It also provides a chain log, which allows us to programmatically upgrade or downgrade a database. And the most important feature of all is that we have a schema differences or comparison mechanism. Additionally, there is a project called Liquibase Kotlin DSL, which allows us to use Liquibase without typing any XML and just purely Kotlin code. If you have any questions, I'm available on the chat or in the conference for anything. Thank you very much.